Yeah, we ended on binomial quadratic equations. We said that an equation is said to be a binomial if after equating it to a zero, it has only two terms. For instance, x squared plus bx is equal to 0. This is first of all, it is a quadratic equation because the highest power on this variable is a 2. But now it is a binomial because it has two terms. We distinguish the terms with either a plus or a minus. So we can have it as x squared plus bx is equal to 0. Two terms. It is a binomial. Or x squared minus bx is equal to 0. It has two terms. Therefore, it is a binomial. But we can also have a trinomial. So in part B, we now want to discuss a trinomial quadratic equation. So a quadratic equation is said to be a trinomial. A quadratic equation is said to be a trinomial if it has three terms after equating it to 0. The very first step is to ensure that everything is equated to 0, and if there is anything common, you add it. Then after equating it to 0, you count how many terms you have on the left hand side. If there are 3, then it becomes a trinomial. For example, if we consider the general form of a quadratic equation, a trinomial quadratic equation, it is ax squared plus bx plus c is equal to 0. This is our first term. This is the second term. This is the third term. They are 1, 2, 3 is equal to 0. So it is a trinomial quadratic equation. If you want to solve a trinomial quadratic equation using factorization method, then you must identify what we call the sum and the product. Our trinomial quadratic equation is given by ax squared plus bx plus c is equal to 0. Now at our level, the sum is the coefficient of x with its c sign. So our sum, our x is this, the coefficient on x is positive b with its sum. With its sign. The product is given by a times c, so it is sc with their respective signs. So if x squared plus bx plus sc is equal to a 0, then in this quadratic equation, this one is the sum, this and this, they are the product. So our product is sc and the sum is a b. Now in an example, we are going to solve the following using factorization method. Part A, we are solving one at a time. We have x squared plus 5x plus 6 is equal to 0. Before doing anything, you first ensure that the quadratic is equal to 0. Now in our solution, I will ask myself, is my quadratic equation equal to 0? Yes. I will rewrite it. It is x squared plus 5x plus a 6 is equal to 0. After equating it to a 0, I write the general form of a trinomial quadratic equation. It is ax squared plus bx plus ac is equal to 0. The third step. Read the coefficients on the variables in which the equation is defined. Our equation is in x. So this is x squared, this is x squared. This is a, there is a silent 1. It means a is a 1. This is x, this is the x. This is a b, this is positive 5. So b is a 5. This is a c, this is positive 6. So a c is a positive 6. After identifying a, b, and c from the equation given by comparing it with the general form, you now state the sum. Our sum of the roots of the equation which we are looking for is a b, and therefore the sum is going to be positive 5. Our product of the roots that we are looking for, the roots that we are talking about are the values of x for this equation. So our product of those two values of x must be given by SC. Where there is a, remove it and you put a 1, because our value of a is a 1. And because it is product, you multiply. Where there is a c, remove it and you put a 6. So the product becomes a 6. So our sum is a 5 and the product is a 6. After getting the sum and the product, you now go ahead and you solve the equation. So our equation is x squared plus 5x plus a 6 is equal to a 0. My sum was a 5 and my product was a 6. We use a product to get the roots that we are talking about. So our product, which is a 6, we are going to look for the factors of 6. So our factors of 6 include 1 times 1 and a 6, because 1 times 6 is a 6. We have 2 times a 3, which is also a 6. And these are the only factors of a 6. We must get the product when it is a positive 6, and it is indeed a positive. Now we want to pick a pair, which when you multiply you get a 6, but when you replace this with a plus, you must get a 5. So we have a 1 times 6 is a 6, but what about when you remove this and you put a plus? Because we want the sum to be 5. 1 plus 6 is 7, which means 1 and 6 are not the values that we are looking for, because they give the product as a 6, but when you add them, you don't get a 5. 2 times 3 is a 6, but what about 2 plus 3? 2 plus 3 is a 5, and because our interest is in getting a 5, it means this and this are the values that we are interested in. When you multiply them, you get a 6, and when you add them, you get a 5. So we shall have x squared plus 5x plus a 6 is equal to a 0. Now, instead of having a 5x, we are going to remove it and we put a 2 plus 3. So we shall have x squared plus 2x plus 3x plus a 6 is equal to a 0. After equating it to a 0, you now create 2 brackets. We have 1, 2, 3, 4 terms. So you separate them and have 2 under 1 bracket. So we have x squared plus 2x. These are 1, 2. Now plus 3x plus a 6. All that must be a 0. Look for what is common here and there. This is x squared, this is 2x. So x is common. Pull it out. You remain with, if you want to get what remains here, you get this divided by what you have pulled out. So x squared divided by x is, you keep the base and subtract the powers, so it is x. Then 2x divided by x is a 2, so plus a 2. When you multiply this times this, you get this. This times this, you get this. Plus. What is common here and there is a 3. Pull it out. 3x divided by 3, you remain with x. Plus 6 divided by 3, you remain with a 2, is equal to 0. This bracket must always be the same as this if you're using factorization. So if you get different brackets, there is a reason to worry. Now you correct these ones to form the zero principle, the zero product principle, which says P2 should be a 0. We want two brackets that we multiply and we get a 0. So you begin with this one, which is common. It is x plus 2. Then you open the bracket and you write what is remaining. The first one is x plus a 3 is now equal to 0. We now have this. And once you have the 0 principle, it means either this is a 0 or the second one is a 0. So either x plus a 2 is a 0 or x plus a 3 is a 0. So our x plus a 2 is a 0. We want to remain with only x on this side. So x plus 2 minus 2 is a 0 minus 2. And our x is going to be negative 2. X plus 3 is a 0. We want to remain with only x. So x plus 3 minus 3 is a 0 minus 3. And our x is negative 3. Which means x is a negative 2 or x is negative 3. Those are the two values of x for this quadratic equation. So that was part A. Then part B says we have 6a squared plus 11a is equal to negative 3. We want to solve this and we get the values of a. The very first step in the solution, this is the question before us, but you can't do anything on this unless when it is all equal to 0. So we are going to begin by moving this one this side so that everything is equal to 0. So 6a squared plus 11a is equal to negative 3. This is what has been given. We want to transfer this side. So if it crosses an equal sign, it becomes a positive. Because it is negative, the other side. We are supposed to move it to where a squared is. So 6a squared plus 11a plus a 3 is now equal to negative 3 plus a 3. So 6a squared plus 11a plus a 3 is equal to 0. After equating it to 0, write the general form of a quadratic. So our 6a squared plus 11a plus a 3 is a 0. But the general form is now a. Because this one is in terms of a, we are not going to use, it is a x squared plus bx plus a c is equal to 0. This is a square, this is a square. This is a, this is a 6. So our a is a 6. This is x, this is a. This is b, this is 11. So our b is 11. This is a c, this is a positive 3. So a c is positive 3. 6a squared plus 11a plus a 3 is a 0. If you don't want to think about it this way, you can say this is the same as capital A squared plus capital BA plus a c is equal to 0. So your capital A is going to be a 6, but capital A is the same as small a. Your capital B is going to be 11, but capital B is the same as small b. And your C is a 3, so C is a 3. You still get the same values. After getting these, then you set the sum is equal to the value of B. Now what is the value of B? It is 11. So our sum is 11. The product is SC, but A is 6, C is 3. So our product is going to be 6 times 3, and 6 times 3 is 18. So the sum is 11 and the product is 18. Now we said we use the product, not the sum. We use the product to look for the factors. So our sum is 11 and the product is 18. We look for the product. So we are going to look for the factors of 18 because 18 is the product. We can have 1 times 18, which is 18. We can have 3 times 6, which is 18 still. We can have 2 times 9, which is 18. And those are the only factors of 18. So we are going to look for 2 numbers, which when you multiply, you get 18, which is what is here. But when you add them, you must get 11. We are testing the first part. 1 times 18 is 18. This is for the product. But what about the sum? 1 times 18 is 18. 1 plus 18 is 19, which means this will not work. 3 times 6 is 18, but 3 plus 6 is 9. We are looking for 11, so this one will also not work. 2 times 9 is 18, but 2 plus 9 is 11. Because we are looking for 11 and 18, this pair is going to work. So our equation was a 6a squared plus 11a plus a 3 is equal to 0. Now where there is 11a, you remove it and you put a 2 plus 9. So we shall have 6a squared plus, instead of this 11, you put a 2 plus a 9, a plus 3 is equal to 0. Now you multiply this a on all the values. We shall have 6a squared plus 2a plus 9a plus a 3 is equal to 0. This is a. Or you may skip this and write this one. You just say, since my 2 numbers that I'm supposed to add are 2 and a 9, so you write 2a plus 9a instead of 11. Now after forming the 4 terms, 1, 2, 3, 4, we said you regroup. So you shall have 6a squared plus 2a under 1 bracket. Then plus 9a plus 3 also under 1 bracket, and we equate to a 0. Now if you go to the brackets, you always trace which one is smaller than the other. This one is smaller than this. So you first pull out that 2a because it is smaller. 6a squared divided by 2a, we shall have 3a. 2a divided by 2a plus a 1. Now you also got the second bracket and you trace what is smaller, 9a and 3. 3 is smaller, pull it out. Then say 9a divided by 3, you will get 3a. 3 divided by 3, you get a 1 is equal to 0. So 2a plus a 3 It is what is remaining, and the common bracket is a 3a plus a 1. So either we are now on the 0 principle because we have two brackets which we are equating to 0. So either 2a plus a 3 is a 0, or 3a plus a 1 is a 0. So our 2a plus a 3 minus a 3 is a 0 minus a 3. So 2a is a negative 3, and a is negative 3 over 2, which is the same as negative 1.5. 3a plus a 1 is a 0, so 3a plus 1 minus 1 is a 0 minus 1. So our 3a is a negative 1, and a is negative 1 over 3. So a can either be this, or it can be that. Now, as an exercise, let us try out the following. Solve the following quadratic equations. Part A, we have 2x squared minus 4x minus 8 is equal to negative x squared plus x. First, ensure that everything is equal to 0. You collect the like terms. Part B, x minus x over x minus 1 is equal to x minus 2 over x minus 1. Hey, you also solve that. Hint. The first one, which was 2x squared minus 4x minus 8 is equal to negative x squared plus x. We begin by ensuring that everything is equal to a 0, and we have a trinomial quadratic. So when this one crosses an equal sign, because it is negative, it becomes a positive. So we shall have 2x squared plus x squared. When this one crosses an equal sign, because it is a positive, it is going to become a negative. So minus 4x minus x. Now minus 8 is going to be 0, because all these ones have crossed. Or you can say it will be negative x squared plus x squared plus x minus x. Then you conclude and say that x squared plus x, 2x squared plus x squared minus 4x minus x minus 8 is equal to 0. We must have a trinomial. So x squared, we add the coefficients. This is a 2, this is a 1, so 3x squared minus x, negative 4, negative 1. So minus 5x minus 8 is equal to 0. Then you solve this using the methods that you have dealt with. Part B, it is x minus x over x minus 1 is equal to x minus a 2 over x minus 1. You first look at all the numerators in our solution. We are giving a hint, then you solve the quadratic. We have 1, we have x minus 1 and x minus 1. So it means our LCM is x minus 1. LCM, you get this times this times the other one. Okay, we have 1, then x minus 1 and x minus 1. So x minus 1 and x minus 1. This is a 1, you don't need to think about it. By what? By x minus 1. This is a 1, this is also 1, which means the LCM is x minus 1. So you multiply all through by x minus 1. So you will have x over 1 times x minus 1 minus x over x minus 1 times x minus 1 is equal to x minus 2 over x minus 1. Then here you introduce the brackets everywhere. Times now x minus 1. So here we shall remain with x into x minus 1. This goes with that. We shall remain with minus x. This one goes with the other one. We shall remain with x minus 2. So x times x is x squared minus x is equal to x minus 2. We must equate everything to 0. So when this one crosses, let us first simplify this. So we shall have x squared minus 2x is equal to x minus 2. When this one crosses an equal sign, it becomes a negative because it is a positive here. So x squared minus 2x minus x. This is a negative, so when it crosses, it becomes a positive. Plus 2 is equal to 0 because all these ones have crossed. Now x squared minus 3x plus 2 is 0. Then you solve this using the methods that we have discussed. Now, having given a hint for this and this, then you will generally look at these ones as an exercise still. So these were trial questions because we have given a hint. Now an exercise. You will solve the following using factorization method. Part A, we have y squared minus 7y plus 12 is equal to 0. Part B, we have 5x squared plus 6 is equal to negative 17x. Part C, we have 3 over a minus 1 plus 1 over a minus 1 is equal to 2. Part D, we shall have 2x plus 3. Okay. Part D, we shall have 2x plus 3 over x minus 3 minus x is equal to 9 over x minus 3. Then part E, we shall have 1 over x minus x over x minus 1 is equal to a 1 over 6. You can try out those and you put the solutions to this email. It is Asumani tiaba4@gmail.com, or you can put them, you can scan using WPS Occam scanner and you put the solutions on 0701 600 343. This is for WhatsApp. Thank you for listening, and in our next discussion we shall look at the applications of the zero principle and also how to solve the quadratic equations, solving quadratic equations using completing squares. Thank you for listening. We shall look at the applications of the zero principle and how to solve quadratic equations using completing squares. Thank you for listening. Put your solutions on this, or that you can as well follow me on YouTube. My channel is Mtiaba Asumani. Thank you for listening.